Okay, in this video, we're going to be doing problem set 62 from Calc AB. The problems and a playlist are in the description below. Let's take a look. First up, we want to evaluate d dx, or the derivative of 8 times the quantity sine of square root of x to the fifth. So it's really like sine to the fifth. So I think what I would do is I'd probably rewrite this because this is how in my mind I envision this. So the first thing we're going to do is take the derivative of something to the fifth. That's going to be 5 times that thing. But there's an 8, so 5 times 8 is 40, so we're going to get 40, that thing, which is sine of square root of x to the fourth, times the derivative of that thing. That thing is sine. The derivative of sine is cosine of that thing, so cosine of root x, times the derivative of that thing, which is the derivative of square root of x, is 1/2 x to the negative 1/2. So we get this. And then there's not much you can do here. You can like simplify the 40 and the 1/2 to give you 20. And you can take the x to the negative 1/2 and put it in the denominator. So a final answer, like multiple choice or whatever, might look like 20 sine to the fourth root x cosine root x all over root x. That's the first question. Let's take a look at the next one. All right, we're going to find dy dx, or the derivative of y equals x cubed times the quantity e to the 3x minus 2. All right, so it's a product, so we're going to use product rule. So our derivative is going to be first, so x cubed, derivative of the second, 3e to the 3x, plus second, which is that whole quantity, times the derivative of the first, which is going to be 3x squared. Now, if you look at this, both terms have a 3 and an x squared in them, so we can take 3x squared out. It doesn't really simplify all that much. Take 3x squared out, and then you're left with x e to the 3x plus e to the 3x minus 2, which in factored form I think is how the answer would definitely look. Let's take a look at the next problem. We want to evaluate the limit as h approaches 0. As soon as you see that, you're thinking this is the definition of the derivative, and you just have to say the derivative of what? So limit as h approaches 0, secant of 5 times the quantity x plus h minus secant of 5x all over h. So it's limit as h approaches 0 of f of x plus h minus f of x all over h. So that minus f of x tells you what f of x is. F of x is secant to the fifth. So we just need the derivative of that. We know the derivative of secant is secant tan, but we got some chain rule here. So it's going to be 5 secant 5x tan 5x. And that 5 is there because of the chain rule. All right, let's finish writing that. And we'll take a look at the next problem. So we want to find the critical points of the absolute value of x squared minus 3x minus 4. So this doesn't tell us how to do this. So I'm going to do it more or less graphically, I guess. For starters, I'm just going to factor the thing that's inside there. It's a quadratic. So I know offhand quadratics definitely have a critical point at their vertex. So if I can find the vertex, that's going to be one of the critical points. I'm also going to construct the graph. So here we go. We got -1 and 4. And then ordinarily this would be a quadratic that opens up without the absolute value. It's quadratic that opens up and has x-intercepts at -1 and 4. So you basically draw that, but anywhere that quadratic would go negative, which is in between -1 and 4, you reflect it over the x-axis. So being able to do this is really useful. Think of the normal graph, and anywhere the normal graph is below the x-axis, just reflect it over the x-axis. That's how we get this graph. Now you can see by looking at this that we have critical points at -1 and 4 because the slope definitely does not exist there. So the derivative doesn't exist. That's a critical point. So I'm going to write those down. So critical points -1 and 4 because f prime does not exist there. Now, between -1 and 4, there's also a critical point because somewhere the slope is 0. It's going to be at the vertex, and the vertex is always at the average of the x-intercepts of a quadratic. So, if you average -1 and 4, you get 3/2. Another approach is to say that between -1 and 4, instead of having x squared minus 3x minus 4, we have the opposite of x squared minus 3x minus 4, right? Because you're below the axis, so you take the opposite. If you have the opposite of x squared minus 3x minus 4, then that means the derivative is the opposite of the derivative of x squared minus 3x minus 4. So the opposite of 2x minus 3. So I'm going to write that down. Between -1 and 4, f prime of x is the opposite of the derivative of x squared minus 3x minus 4, which is 2x minus 3. Now from there, you can definitely see the 0 of that is 3/2, so we have a critical point there. So I'm going to say critical point at x equals 3/2 because f prime of 3/2 is equal to 0. That's the entire problem set. I hope this was helpful, and good luck.